I'm Dr. Bennet McComish, and I work at the Menzies Institute for Medical Research at the University of Tasmania. When I'm not doing science, I like to brew beer. I brew some award-winning home brews, quite often win prizes in the state competition, occasionally in the national one. And I also train in historical swordsmanship. Quite a really interesting biological problem, the way that MS risk is manifested from a genetic point of view. The fact that there's a very distinct geographical and sort of ancestry pattern to the prevalence of MS suggests that there's likely to be an influence of natural selection. And my background is in evolutionary biology, so that interests me a lot. And of course, I've got a lot of colleagues around me here at the Menzies who do really good work on MS. And so that's really, it's really them that have inspired me to get into MS research and to find interesting biological problems in it. So I think the work that's been done on Epstein-Barr virus last year in particular, there was a study that came out that showed that Epstein-Barr virus is pretty much an obligatory factor in developing MS. So you're not going to develop MS without first being infected by Epstein-Barr virus. And that has some interesting implications in terms of the selection pressures on our immune system in responding to the virus and how those might have shaped risk. So my project is to look at the impact of natural selection on MS risk and how the risk variants that we see in the genome are likely to have been shaped by natural selection. As I've said, the geographical pattern that we see in MS prevalence, and in particular the latitude gradient, is very similar to what we see for some traits that have been under strong natural selection. And so if we look for signatures of natural selection in the genome and look at where they overlap with MS risk loci, that might help us to narrow down which actual genes are involved and what the biological processes are that are involved in increasing risk of MS. My research is aimed at trying to narrow down the actual genes and biological processes that are involved in increasing MS risk or causing MS. And knowing what those processes are, understanding those better, will help us understand the likely targets for therapies to treat MS or to perhaps even to prevent MS. Well, so I don't work in the lab in a traditional sense. My work is all computational, so my lab effectively is a high-performance computing cluster, and that has advantages and disadvantages. It means that most of my work is sitting in front of a computer, which is not great, but that also means that I can do it from anywhere and really any time that suits me. It poses some quite interesting challenges sometimes. There's some interesting detective work and problem solving that I have to do, which is fun.